Hi, I'm Adolph Oliver, and in this lesson we're talking about adding and subtracting real numbers, which implies that what we're doing here is adding and subtracting numbers that can have either plus or minus signs. Now, first question is, what does a single sign in front of a number tell us? Well, that simply just tells us where the number is on the number line. So, for instance, if I sketched in a number line here, and put some positive tick marks going to the right and some negative ones going to the left here. This would be plus 1 and plus 2 and plus 3, and this would be negative 1 and negative 2 and negative 3. Well, of course, if I had a number that was one that had a plus in front of it, that would simply mean I'm located right here at this point. And on the other hand, if I had a number that had a minus in front of it, like minus 3, that would mean I'm located right here at this point. So a single sign in front of a number simply tells us where we are on the number line. Now, the question is, of course, what does it mean if we have more than one sign in front of a number? Let's say that I'm starting at negative 3 here, and I want to put another minus in front of it. Well, the first thing you have to get used to is this. In mathematics, we always have to separate signs by parens like this. You can never have two signs next to each other without having some parens separating them. Well, here we go. I'm starting at the guy inside here at negative 3. What does this extra minus in front mean? Well, here's the idea right here. Extra minus means take the opposite of. So, wherever we are, if I'm at negative 3 and an extra minus in front, which means take the opposite of, taking the opposite simply means go the same distance, but on the other side of the number line. So if I'm here at negative 3, the starting point, and I've got this extra minus in front, I'm going to end up over here at positive 3. Well, what if I had an extra plus in front? And remember again, we always have to have the parens to separate the signs like this. In this case, I'm starting at negative 3, but the extra plus in front means this: stay where you are. So, starting at negative 3, the extra plus in front means stay where you are, so we end up at negative 3. We don't move at all. Okay, well, let's take a look at this now a little bit more thoroughly here. Let me sketch in a number line here. Here it is. And again a 0 and a couple of tick marks to the right and a couple of tick marks over here to the left. Well, let's see. Starting over here, 2 tick marks to the right, this is officially plus 2. Well, what if I put an extra minus in front of that plus 2? Here it is. Remember, this is where we're starting, plus 2 right here. But the minus means take the opposite of this. Well, what's the opposite? The same distance, but on the other side of the number line. So where do we end up over here? We end up at negative 2. We started, of course, at plus 2. Well, now, let's say that I start at plus 2 again, but this time I'm putting an extra plus in front. Again, where are we starting? At plus 2, the guy on the inside here, but the extra plus means don't move, stay where you are. So that means we stay right here at this point. Okay, well, let's play the same game starting over here at negative 2. If I start at negative 2 and put an extra minus in front, well, I'm starting at negative 2, the guy on the inside here, but the extra minus says take the opposite of, which means I've got to go the same distance, but on the other side of 0, so I end up at plus 2. Well, there's one last thing we can do in this sketch. And that is, let's start at minus 2, but put an extra plus in front. Okay, well, we're starting at negative 2, but the extra plus simply means stay where you are. So where do we end up right here? Where we started at minus 2. Well, you look at this and say, this is an interesting little demonstration here. But what's the real point? Well, somewhere along the line you probably learned about what's known as the like and unlike rules for combining signs. And what I've just done by this little demonstration is snuck to you these rules. Let's point this out. Like signs, the like rule means we have like signs. I'm going to leave the numbers out and just put the signs down. But we could have both numbers being positive, or we could have both numbers being negative. Well, either way this works, you end up with the same final sign. Let's demonstrate this to you. See these two pluses? That meant we had two pluses in a number, like this case right here. Where'd we end up at? +2. See the two minuses down here? Well, here's our example where we had the two minuses. Where do we end up? At plus. So you can see very readily here why the like rule says, well, if you have like signs, both the numbers are positive or both are negative, you can combine the signs to a single plus. In other words, if there are two pluses in front of the number or two minuses in front of the number, you can combine them to a single plus like we've done these two cases here. Well, the other rule, the unlike rule, let's sketch that one in. There, the signs are different from each other. You could have a minus in front of a plus or a plus in front of a minus. These are unlike signs. They're different from each other, hence the name unlike. Like over here, the signs were the same, hence the name like. Well, look at our example again. If we had a minus and a plus in front of the number, this case right here, where'd we end up? Negative. What if we had a plus and a minus in front of the number? Well, that's this case right here. Where'd we end up? Negative. So we see that if you have unlike signs in front of a number, a minus and a plus or a plus and a minus, they can be combined to a single minus by the demonstration we showed you up above. And of course, remember, all of that's based on the simple idea we mentioned earlier that an extra minus means take the opposite of where you are, and an extra plus means stay where you are on the number line. Well, okay, the like and unlike rules are probably the rules for combining signs that you may have run into in the past, but now let's do a little more looking to see how we can even make an improvement on this. Okay, let's now look at this number right here. What we've got in this case is a number that has a whole bunch of signs in front of it. You see this 3 right here? Well, it's got a minus and a plus and a plus and a minus and so on in front of it. And of course, we have to separate all those signs with parens like this. So here they are, and all the right matching parens are over here that match the guys on the left. Well, the final sign on this is either going to be a +3 or a -3. You know it's going to be one or the other, but the question is which one? Well, we can use the like and unlike rules to be able to work this up. You could start on the left or start in the middle here. I'll start in the middle. And we're just going to use the rules to combine these signs two at a time because, of course, the like and unlike rules only can handle two signs at a time. So a plus and a minus here is unlike. They combine to give me a minus. Well, take that minus and combine it with the next guy who happens to be a plus. The minus and the plus give me another minus. Combine him with the next guy here. The two minuses give me a plus. Combine that plus with the next guy, which is a minus. We get a negative. Well, we keep doing this as we go along. The plus and minus here give me a negative. The two minuses give me a positive. The minus and the plus give me a minus. The plus and the minus give me a minus. And the plus and the minus give me a minus. And finally, the two minuses here give me a plus. So after all of that, what we find out is that this whole thing then equals +3. Well, there's an easier way to be able to do this. I mean, the like and unlike rules definitely work, but it's a lot of work using them if you can only combine them two at a time. So here's a nice little demonstration to show you something. Let's start with, let's say, minus 2. And I've only got a single minus sign in front of it, so of course that means exactly where you are in the number line. So we don't have to do any combining. Remember, rules are only to combine if you have more than one sign in front of a number. Okay, let's now put an extra minus sign in front. Well, the two minuses now, by the rules, the like rule, combine to a plus. So this is equal to a plus 2. Okay, well, let's continue this pattern a little bit further here. Let's put even one more minus sign in front. So we've got to have parens around everybody like I'm showing you here. Well, the first two minuses give me a plus. That plus combines with the minus in front to give me a minus 2. Now you may notice a pattern setting in here, but let's look at it once more here just to see it thoroughly. Let's put even one more minus in front. Here we are. Okay. Well, the first two minuses give me a plus. That plus combined with the next minus give me a minus. That minus compared with the minus in front give me a plus. So, by using the like and unlike rules like we did up above here, we can see the signs that we get as we combine all of the minus signs that we have here. Well, notice what's going on. The signs are alternating here. In particular, when we have an odd number of minus signs, one minus sign in front or three minus signs in front, the final answer is negative. On the other hand, if we have an even number of minus signs in front, 2 for instance here, or 4 down here, the final answer is positive. What this does is allows us to set up another rule for combining signs, just like the like and unlike rules, but we're going to call this the even and odd rule for minus signs. Okay, now remember, when we had an odd number of minus signs, and we saw that up above here, when we had either 1 or 3 minus signs, the answer was negative. So you can see why we say down here that when you have an odd number of minus signs, the answer is indeed negative. Well, an even number of minus signs, and that was the case up above here where we had 2 minus signs or 4 minus signs, the number or the final sign is positive. So here's a new rule which is just like the like and unlike rules. I like to call it the even and odd rule for minus signs. And what it does is says if you have an odd number of minus signs in front of your number, then it can be combined to a single minus. If you have an even number of minus signs, it can be combined to a single plus. Now you may have noticed here that we haven't mentioned anything about the positive signs. We're just talking about the even and odd rule for minus signs. Well, there's a very good reason for this. Remember that a minus sign means take the opposite of, and that means you're making a change with a minus sign. But remember, the plus signs mean stay where you are, which means that there's no change with a plus sign. So what it boils down to is you just have to figure out how many minus signs you have in front. They're the ones that are causing the change. The plus signs don't cause any change. They stay where you are. So that's why this even and odd rule works for just minus signs. We don't have to keep track of the plus signs. Well, now let's go back up to that long guy that we did to begin with up here. And let's count how many minus signs we have. Here's one right here. Here's the second one. Here's the third one. Here's the fourth one. Here's the fifth one. and there's the sixth one. Well, you've got here 6 minus signs. Okay, well, if you'd known about the even and odd rule, you could have just counted up those 6 signs, and of course remember, an even number of minus signs means the sign of the final answer is positive. That means you could have been up here and just said, well, 6 minus signs, that's an even number. The answer has to be positive 3, and you get it a lot quicker. Okay, well now, let's go down here and take one last look at this even and odd rule for minus signs. I want to point out to you how you can easily remember which way this goes. Now, you'll of course remember, well, okay, if there was an odd number of minus signs, it combined to a single sign, and if it was an even number, it combined to a single sign, but which was which? Real easy. Just think of a number with a single sign in front. Okay, minus 3. Well, a number with a single sign simply tells you where it is on the number line. So this guy is definitely negative. And guess what? This is 1 minus sign. That's an odd number. So you can use an example like this to always remember easily that an odd number of minus signs gives you a negative for the answer. And then the even number of minus signs just has to be the other guy, the plus. Okay, well now, let's talk about how we start using these. And there's something that you have to be very careful with here. How the rules get used is different whether you're adding and subtracting or multiplying and dividing. And this is something that you have to focus on very carefully. At the moment, we're going to talk about how you use the rules to add and subtract. Now remember, when I'm talking about rules here, you can use either the like and unlike rules or the even and odd rule for minus signs. They are both equivalent to each other, and they give us the exact same answer. Well, let's take a look first at an important point here. You cannot use the rules, either like and unlike or even and odd, to get the sign of the final answer. And here's a classic example. Minus 4 minus 3 equals. Now, if you're not careful with this, you'll say, oh boy, look at this. 2 minus signs, and by the rules, they're like signs. This should be a positive answer. Well, you're absolutely wrong in that case. Okay, let's take a look at what's really going on here. We've got minus 4, and then we're subtracting 3 more. Okay, one of the ways you can do something like this is work it up with a number line. So here we go. Let's say this is 0, and let's say right here is negative 4, and I'm starting at negative 4 here, so here's my starting point. But now, from there, I've got to go negative 3. Well, of course, the negative direction is to the left, not to the right. That would be the positive direction. So if I've got to go negative 3 here, I start at my negative 4, and I go negative 3 more over to the left. Where do I end up with? Well, 3 more units to the left here, you end up at negative 7. So, here it is, negative 4 minus 3 equals negative 7. Okay, well, the reason why the rules don't work here, of course, is that these 2 minus signs are not in front of the same number. They're one in front of each. So you have to watch out for this. The rules work if you apply them correctly. And again, here's the point. If you are adding and subtracting, you cannot use the rules to get the sign of the final answer. Okay, what you have to do is one of the methods we're going to talk about now. So, let's take a look at my next example here. Here we go. Adding and subtracting sign numbers is all the same, and here's an example that I've got right here. Notice that some of these guys are being added, some of these guys are being subtracted. We're going to use exactly the same method to analyze this, whether you have adds or subtracts. Sometimes you guys are taught different methods for adding sign numbers and subtracting sign numbers. There's no reason in the world for that. It's all exactly the same thing. Now, let's talk about the method that we're going to use here. Then we'll come back and use it on this example. Here we go. Here's the method we're going to talk about. We're going to use the rules to get a single sign in front of each number. That then is the end of using the rules as far as adding and subtracting goes. After that, we'll get the final answer by combining the numbers using one of three methods. One of these I've already snuck to you already. That's the method known as the number line. Then I'm going to talk about positive and negative parts. This is basically what you do in your head to keep track of how much positive and how much negative you have. And then we'll point out using a calculator down here. Some of you guys think, oh boy, I'm going to use my calculator to get the answer. Well, most likely you're going to get it wrong with the calculator, and I'll point out to you why. Anyway, let's go back to our example that we have up here. Remember, the first thing we're going to do here is we're going to use the rules for only one thing, to get a single sign in front of each of these numbers. That's all you can use the rules for when it comes to adding and subtracting. Now, let's take a look at what we have. Notice the guy out in front here already has a single sign in front, so we don't need the rules for that one. The -4 just simply stays as -4. But now, the rest of these guys have more than a single sign in front. The 2 here has a pair of pluses. Well, by like and unlike, or even an odd if you wish, but since we have two signs here, like works fine. The 2 pluses combine to a single plus, so this is officially a +2. Now, moving over to the next guy, the 3 has 2 minuses in front. Well, those are like signs, which also combine to a plus, so that is a +3. Moving on to the next guy, the 1 has a plus and then a minus in front. Well, those are unlike. They combine to a single minus. And the guy in the end, a minus and a plus are unlike. That combines into a single minus. So what I've done is I've used the rules here where we've had more than one sign in front of a number. And remember again, when I say rules, you can use like and unlike or even and odd. They're entirely equivalent to each other. And what I've got now are all the numbers but with single signs in front. Okay, well, after you have that, then you can figure out what the answer is, but you can't use the rules anymore. The rules can only be used to get single signs. Okay, how do we come up with the final answer? Well, first, let's number line this. So we can see the numbers we got up above here, -4, +2, +3, -1, -5. If I make a number line down here, then I can start moving back and forth on this number line to show where we are. Okay, here's the number line right here. And let's see, we're starting at -4. So let's say we've got 0 over here someplace, and let's say that this is -4 right here. Okay, there's my starting point, -4. Now, what's happening, of course, is that I've got to go +2. Well, from -4, where's +2? I go +2 in the positive direction here. And where do I end up when I do the +2? Well, if I go 2 units to the right of -4, I end up right here at -2. Well, okay. I started at the -4, I did the +2. Now we got to do +3. Well, +3 means I'm still going the right, but 2 of the units take me to 0, and 1 more of that 3, so the total is 3, I end up over here at +1. So, I started at -4 right here. I had to go +2, that got me to -2, and then I had to go +3, that got me to +1. Okay, now the next thing up is we've got to do a -1. Well, the negative 1 takes me back here to 0. Okay, so that's where I am at the moment. And now there's one last guy to do here. The negative 5, well, I'm at 0 right here. So I now do the negative 5. That means I've got to go to the left. Well, where do I end up? All the way over here, my final answer, at negative 5. So, here's what happens with the number line, and the number line works fine if you've got nice simple integers like this and the numbers aren't very big. Pick your starting point. Any numbers that are positive, go to the right. Any numbers that are negative, go in the negative direction to the left. And once you've used everybody up, see where you end up with at negative 5. Well, there's a much easier way to do it than this. And that's the method I call down here positive and negative parts. Okay, here's the idea. Let's go back up and take a look at our problem up above. We, of course, use the rules to get a single sign in front of everybody. We needed those single signs to know which way to go if we were doing the number line. Anybody with a plus, we went to the right. Anybody with a negative, we went to the left. But now, here's the other thing we can do. We can add up the total amount of positive here and the total amount of negative that we have. Well, let's see what the positive guys are. I'll underline them. We only have these two positive guys right here. The plus 2 and the plus 3. Well, the total positive then is 5. How much total negative do I have? Well, the guys that are not underlined are the negatives. Negative 4 minus 1 is minus 5, and another minus 5. The total negative is 10. Okay, well, once you've got the total positive and the total negative all combined, and we, of course, have it labeled here, so this would be a plus 5 and this would be a minus 10, but since I've got them labeled, that suffices. It's like a baseball game. Who wins and by how much? Well, negative is the winner right here. It's got more than positive. And how much did it win by? It won by 5. Okay, well, that means our answer is negative 5, exactly the same answer we got when we number line the thing down here. So this positive and negative parts business here, combine all the positives, combine all the negatives, see who wins and by how much, and that's the final answer. Negative wins by 5, so that implies the answer, of course, is negative 5, exactly what we got down here with the number line. Now, the beauty of the positive and negative parts business is it can handle larger numbers and even decimals and fractions, whereas that would absolutely drive you nuts on the number line. But the number line is a nice visual way to see what's going on. But the positive and negative parts is much easier to come up with the answers. Now, of course, I mentioned down the bottom here being able to use a calculator. Well, let's go back up and take a look at what we've got up above here. Let's look at the original problem. If you have a calculator that has in it left and right parens, it is possible, if you were very, very careful, to key in exactly all the signs, the numbers, and the left and right parens, and come up with, of course, the answer negative 5. But if you got just one parent out of place or one sign out of place, you'd get the incorrect answer. And the chance of being able to key all these guys in correctly with all those parents and everything is pretty slim. It is much safer, even if you're going to use your calculator, to first combine the signs into single signs like we've done right here. So that's why I say down below here, no matter what of these methods you're going to use, whether it's the number line, positive and negative parts, or a calculator, you always want to use the rules to get a single sign in front of the numbers before you use any of these methods. Well, if we use the rules to get a single sign in front, then this is what you're looking at right here. All these guys with single signs. And now it's much easier to key this into your calculator. Okay, -4 plus 2 plus 3 minus 1 minus 5. Much greater chance of getting it correct. But there's one other problem. You see this minus in front? That's not the regular subtract button on your calculator. The subtract button means you've got to have numbers in both sides like we have further along here. This guy in front means that we're starting with a -4. Now, some calculators have buttons where you see a plus minus on the button, or sometimes you see somebody that has a button that's CHS for change sign. Okay, those are both examples of buttons that you might have on a calculator that would take care of this problem. You'd key in the 4, hit either the plus minus or the CHS button, and that would make it a -4. And then after that, all the rest of the signs that you see here, the pluses and the minuses, are your regular plus and minus signs on your calculator. Then you'd simply hit the equal sign at the end, and you'd come up with the answer. Well, you may not have a fancy calculator that has a plus minus or CHS sign, so there's another way that you can get around this. You may recall that there's a number which if you add it to anything, it will not change the final answer, or if you subtract it, it will not change the final answer. And of course that magic number is 0. So watch what you can do. You see this -4 to begin with? You could put a 0 out in front, and now that minus sign becomes the regular minus sign in your calculator. But combining a 0 in will not change the final answer at all. So if you ever have numbers like this to put in your calculator and the beginning one has a minus in front, remember this trick. Key in 0 to begin with, and then all the regular pluses and minuses after that are the regular plus and minus signs in your calculator. And if you were to now do this whole thing, you'd of course end up with the -5 answer here, just like we got by the other methods. But of course by the time you did all of this and you had it with single signs, it's much easier just to get the positive parts and the negative parts and get the answer using the positive and negative part situation. The -10 here wins over the +5. It's the winner by 5, and that of course means the answer is -5. Okay, well, keep in mind now what we've talked about is for rules. We have both the like and unlike, or the even and odd rule for minus signs. You can use any of those when you combine signs, but when you're adding and subtracting, you cannot get the sign of the final answer using the rules. You can only use the rules to get a single sign in front of each number. Then after that, you either have to number line it, or do the positive and negative parts thing, or you can use your calculator if you want to, but I think this is faster, and come up with what the final answer is. Okay, well, now that we've talked about all of the methods here, let's look at some examples. They're going to seem pretty simple after we've talked about all the details here. Okay, here's our first example. We've got both the signs, or both the numbers here, in effect have just a single sign in front. Notice there's no sign showing out in front here. So the 1 here simply is a -1, and the 5 here is simply a +5. In other words, you don't need the rules at all for this problem. And you can combine this. Now, if you do this in your head, you're officially doing positive and negative parts. Let's mention that down here. What's the total positive? Well, the only guy that's +5. What's the total negative? Well, the only guy that's negative is the 1. Who's the winner in this case? Well, positive wins by 4. So that means the final answer here is positive 4. You could put the plus in front of the answer here if you want, but remember, if folks see a number without a sign, they will assume it's positive. So if your answer is positive, you can leave the sign off or put it there if you want to. You can go either way. Okay, well, let's look at another simple example. Once again, we do not need the rules here. Both these numbers have a single sign in front. So this is simply minus 4, and this is simply minus 1. Okay, let's use our favorite positive and negative parts routine. And of course, many times you do this in your head. I'm just writing it out here to again remind you of the process. But when you think about combining positive and negative parts in your head, you're using this same process right here. What's the total positive? Well, notice both these guys are negative, so in this particular problem, the total positive is 0. Well, these guys are both negative. What's the total negative? 4 here and 1 here. So the total negative is 5. Well, this is a shutout in a baseball game here. Who's the winner? Negative by the full 5. So the answer here has to be negative 5. Okay. Well, this works whether you have nice whole numbers or decimals or fractions. Let's take a look at a fraction example. And here's one here where we're actually going to have to make use of the rules here. Not for the first fraction. Notice the 2/3 has just a single sign in front. So this is negative 2/3. Okay, but the next fraction, the 4/5, has both a plus and a minus in front, more than one sign, so we have to use the rules to combine it here. The plus and minus give me a minus, and we end up with minus 4/5. Now, the answer's got to be negative here since there's no positive stuff in it, but we got one other problem. Notice we do not have a common denominator, so like we have with fractions, we have to figure out what that LCD is. In this particular case, remember that what you do is you guys know what the answer is already, but let me just show you the official way here. Think of the multiples and take the larger denominator because you'll get the answer quicker. Start making the multiples of 5, and the first one that 3 divides into evenly means that that is the LCD. Well, the first multiple of 5 is 5. 3 does not divide evenly into 5. The second multiple of 5 is 10. 3 doesn't divide evenly into 10. But the third multiple of 5 is 15, and 3 does divide into 15. So from that, we can see the LCD equals 15. Okay, well that means, of course, we have to combine, or convert, I should say, these fractions to 15ths. So here we go. Now, remember, we had a minus in front of each of these, so there's the minuses. Now, once again, it's easy to do this, but let's remind you of the process. Compare the old denominator to the new one. What'd you have to multiply 3 by to change it into 15? Well, you had to multiply it by 5. So that means you do the same thing to the numerator. 2 times 5 gives me 10. Okay, 10/15. If I reduce to 5 and the 10, it'd give me 2. If I reduce to 5 and a 15, it'd give me 3. So 5/15 is exactly the same as 2/3. Well, do the same thing over here in the second guy. What do I have to multiply the old denominator by to make the new one? I've got to multiply it by 3. So I do the same thing to the top. 4 times 3 is 12. Now double check this once again. 3 goes into 12 4 times. 3 goes into 15 5 times. You always want to double check these quickly to make sure you didn't make a mistake in doing the converting, because you want to find that out quickly if you did. Okay, well now here we go. We've got the common denominator 15. Here's what you want to do. Take the signs in front with the numerators. You want to keep the 15, positive 15 in both cases. So there's my LCD. Okay, the two 15s match, so we have a common denominator. Now, what do we have for the answer? Well, take the sign in front with the numerator. So you got a minus 10 here and a minus 12 here. Now, play the old positive and negative parts game here. We're getting practice at doing this, so you know how it works. Here we go, positive and negative. Well, notice in this particular problem, as we look at this, there is no positive up here. Negative 10 and negative 12, they're both negative, so again, the positive is 0. The total negative, 10 and 12, is 22. So what do we end up with here? Well, negative wins by the full 22. It's a shutout again. So that means, what do we put up in our answer here? Negative 22 for the numerator. Here it is. Now, you check to see if you could reduce this any, and there's nothing that will divide into both of these guys at the same time. If this is 21, it would work, but not 22. Now, since this is not a word problem, you can leave the answer as an improper fraction like this. So there we are, negative 22/15. Okay, let's take a look at one where we've got a mixed number here. Okay, first off, notice both of these numbers have single signs in front of them, so this is another case where we do not need to use the rules. This guy here is just negative 1 6/7, and this guy here is plus 1/2. Okay, no need for the rules in this problem. Well, the first thing you want to do is take this mixed number and convert it to an improper fraction. 1 times 7 is 7, plus 6 is 13. This is the same thing as negative 13 over 7. And, of course, we still have the plus 1/2. Well, just like in our last problem here, what we've got is a case where we have unlike denominators, so we have to figure out what the LCD is. It's pretty easy to see here what it is. First multiple of 7, 2 doesn't divide into, but the second multiple of 7 is 14, which 2 divides into, so the LCD equals 14. Okay, let's convert both of these guys to 14ths, just like we did earlier. The first fraction has a minus in front. Here's our common 14. The second fraction has a plus in front. Here's the common 14 here. Now, remember how we worked this out. Compare the old denominator to the new one. What did you have to multiply 7 by to change it to 14? You had to multiply it by 2. So we do the same thing to the top, and we end up with 13 times 2, which is 26. Okay, there's the first fraction. If we check this quickly, 2 would go into 26 13 times, 2 goes into 14 7 times, so this 26/14 is the same value as 13/7, only written with the common denominator that we need. Well, over here, what's half convert into? We know what the answer is going to be, but remember again, what do you have to multiply the old denominator by to get the new one? 7. You do the same thing to the numerator. 1 times 7 is 7. And of course, if we reduce this in our minds, 7 goes into 7 once, 7 goes into 14 twice. So this still equals 1/2. Okay, well now, just like we did a moment ago, we've got our common denominator, 14ths here. Here it is. Take the signs with the numerators. Here they are. Okay, play the positive and negative parts game on this. And again, you do this in your head, but I'm writing it down here so you can see what's going on. Okay, here we are, all set. The total positive, well, the only positive guy is 7, and the only negative guy is 26. So negative is going to be the winner here by, let's see, I guess by 19. So that means then that our final answer up here is going to be negative 19. And again, that cannot be reduced. So there we are, our final answer on this one. We did have to use, in this particular problem, or I shouldn't say we didn't have to use the rules, because both the original numbers had just single signs. All the work that was here was just the standard fraction work, and then of course the positive and negative parts down here to figure out what the final answer was. Okay, well, fractions are workable. They're always more work, but there they are. Here's some decimals. Now again, there's a plus in between, so that means these guys are being added, so you know you're doing the adding and subtracting business here. But the first number here, the 3 8/10, has a single sign in front, so we don't need the rules for it. We just write it down the way it is. The second guy, however, we have two signs in front. The plus and minus, by the unlike rule, combines to a negative, so this is negative 7.8. Okay, so we had to use the rules on this guy, but not the first guy. Now remember again, you only use the rules when you're adding and subtracting to get a single sign in front of the number. After that, you've got to use positive and negative parts to be able to come up with what the final answer is, because the final answer is a battle between how much positive and negative you have, and whoever you have the most of, that's the winner. Well, again, in this particular problem, there's no positive. These guys are both negative. The total negative here equals, well, let's see, 8 and 8 is 16, carry the 1, 10, looks like it's 11.6 is the total negative. Well, this is a shutout again. Here's the winner by the full 11.6, so that means the final answer here, negative 11.6. Okay, well, here's another example. Again, we've got to use the rules here. The first number we don't have to use the rules for. It's got a single sign, so we just write it down with that single sign. The second number, however, has two signs in front. The plus and minus, by the unlike rule, combines to a single minus. So here we are, very similar to the last problem. We've used the rules to get a single sign in front of each of the numbers. Now we simply use positive and negative parts on this. Again, no positive. The total negative we combine, it looks like it comes out to be 5 right on the button. So who's the winner here? Well, the negative by the full 5. So that means then the answer here, negative 5. Since it comes out to be a whole number, you don't have to put a decimal point if you don't want to. I mean, you can put a decimal point in a 0, but it's not necessary. Okay, well, let's look at some final examples here. Cases where we've got a few more numbers, like one of the examples I worked for you back when we were discussing this all to begin with. Here we see numbers which are being added or subtracted. They're minus signs, so subtraction going on here. Now that means, of course, we use the rules to get rid of any cases where there's more than one sign in front of a number, and there's one place in this where we have that. The other guys with single signs, this guy out in front, write him the way he is. The two minuses in front of the 8 combine to a single plus, and the guy in the end stays exactly the way he is. Okay, well, you can see what's going to happen here. The plus 8 and minus 8 knock each other out, so the answer is going to be negative 6. But again, let's show you that the positive and negative parts will get the same answer. So here we go. There is a positive one here, this guy right here. So we have positive 8, but the total negative is 14. The 6 and the negative 8 here, these two guys. And who's the winner here? Well, of course, negative wins by 6. So as we saw in our little shortcut here, the answer on this, negative 6. Okay, one last example, but the same idea going on here. Okay, there are a couple places here where we're going to have to use the rules to get a single sign in front of the number. Not with the first guy. He's got a single sign, so write him down the way he is. The 3, however, has 2 minus signs. They combine to a plus. This 2 has a single sign. We don't use the rules here. We just write it down the way it is. But the guy in the end has 2 minuses. That combines to a plus. Okay, well, here we are. We've got single signs in front of everybody. Remember, that's all we can use the rules for. So what's the total positive and what's the total negative? Again, you can do this in your head, but I'm writing it down here just to show you the technique again. The total positives, 3 and 2 is 5, plus another 5. The total positive is 10. There's only one negative guy, so the total negative is just 7. Well, positive is the winner here by 3, so that means the final answer on this positive 3. You could put the plus in front if you wanted, or leave it off just like this.